Okay, this lecture is over Chapter 7 of your textbook, whose title is Lists and Tuples. So, kind of a long list of topics for this chapter, but we'll talk about what sequences are in general, and then how they're implemented in Python as lists. We'll talk about list slicing, finding whether or not items are in a list. We'll talk about built-in functions and methods that we have in Python for doing things to the list. We'll talk about making copies of the list. We'll talk about going through and processing part or all of a list. We'll talk about list comprehensions, which is basically just building a list from another list. We'll talk about two-dimensional list. We'll talk about what a tuple is, which is a special kind of list. And then we'll talk about a little bit about installing packages and using packages, in particular the matplotlib, which is a library or a package for plotting data that is represented within list. So those are all the topics that we will be talking about. Now first, what is a sequence? A sequence is items that are stored in sequence. We can think of this as a one-dimensional array where you have slots to store data, and if you have 5 pieces of data to store, there's just 5 boxes or elements there to store that data in. Python has different types of lists. They have lists that are referred to as lists, which are mutable, which means they can be changed. And they also have something called tuples, which are lists as well, but they're immutable, which means they cannot be changed over time while your program is running. So a list, sometimes, like I said, might use the term array because it's very close to an array, is just a list of items. And when we're doing an assignment statement, we have a variable and we set it to a existing list or a specified list, which is comma separated items in square brackets. And they can hold different types of data even within the same array. So Perl and Python are 2 languages that allow you to do that. Other languages would give you all kinds of errors if you had a numeric array and you tried to store a string in it, for example. If you pass a list name to the print function, it's going to print the entire list in the format that we see above where we're doing an assignment, which is a comma separated list of values within square brackets. There is a list function that can convert certain types of objects into lists for you. Here's some examples. In the first one, we have a list named even numbers, and it has 5 elements and it has 5 even numbers in it. Figure 7.2 is another list, 5-element list, that has names stored in it, which would be strings. And then in 7.3, this is an example. We have something called info, and it has 3 elements. The first is a string, the second is an integer, and the third is a floating point number. So you can mix within a list the data types that are being held. The repetition operator is an asterisk. Basically, if you give a list and say star some numeric value, what it does is it repeats that list n number of times and creates a list that has however many elements are in the list times whatever the numeric value of n is. So if our list had 5 elements and we did *3, our resulting list is going to have 15 elements. I think we've seen this before in a previous chapter. You can iterate over a list by saying for variable in list name, and it will go through in order and look at the different elements in the list. As far as index, index is a position within the array or an offset within the array. Like modern programming languages, Python starts with the first element being at index 0. The second element is at index 1. And then the nth element is at n-1 because we started at 0. Python also allows you to use negative indices, which basically, instead of doing it from the beginning of the list, gives you an index from the right hand side of the list. An index of -1 represents the last element of the array. -2 is the second from last element of the array. So sometimes you need to move from the right hand side or the end of the list instead of the beginning, comma, left hand side of the list. And you can do that with negative indexing. If you try to use an index that's not in the list, for example, if we create a list that has 5 elements and then we put the list name and in brackets we say position 10, we're going to get an index error. So if you ever need to know how many elements are in a list so you don't do this type of thing, or maybe you're calculating an average and need to know how many numbers are in it, there is an len function, which stands for length. And if you pass a list to the len function, it is going to return the number of elements in the list. If you want the index of the last element, that is the length of the list -1. So if we have a 6-element array, the indexes will go from 0 to 5. There is an exception. We talked about exceptions in the previous chapter called index error. So if you think you might be in a situation where you could somehow try to access an element in the array that does not exist, you could use your exception handling knowledge to catch an index error exception and handle that gracefully instead of the program just blowing up. Like we said earlier, lists are mutable, which means they can change. Values can be added to it, they can be rearranged. But here's an example of where the second element of list, that is the element with index 1, is getting assigned a new value. So whatever was there before would no longer be there, and whatever new value was would now be in that second element of our list array. You can use concatenation to join two things together. In the case of list, you can use the plus operator, and what that will do is it will take the first list on the left hand side of the plus sign and stick on the end of that whatever list is on the right hand side. You can use plus equal augmented assignment like we do with math operators to concatenate lists as well. So Python figures out from the context what the right thing to do with the augmented operators, or really any operators. So if they're strings, it's concatenation. If it's numbers, it's addition, for example. List slicing, that's when so far we've talked about an entire list. We've talked about a single element of a list. Slicing is referring to multiple elements but not necessarily the entire list. And the way we do this with slicing is in the square brackets. Instead of putting a single numeric value, we put a value that's referred to as start, a colon, and then a value that's referred to as end. So basically, from the start index to the end index, do something. If we don't put a start value, then it assumes the beginning of the list 0. And if we don't specify an end, it's going to assume from wherever the start point is to the last element of that list. You can include a step value and negative indexes that are relative from the end of the list as well. The in operator, you can basically ask a question, is item in list? So you can say if item in list colon, and if the item is in the list, it will execute whatever block of code is there for the if statement. If it is not, then it will not. You can use the word not as well. You can say item not in list. So that checks for list membership. There are some methods that are built into list, and you get these methods by putting a list name, a dot, the method name, and then any arguments. So there is an append method that will stick a new item onto the end of an existing list. There is a count function or method that will tell you how many items are in the list. There is an index item, which is real handy. If you need to know what position an item is in, you can say list.index and give an item, and it will find the first occurrence from the beginning of the list and return that value. Now, it will raise a value error if the item is not in the list. Some languages would return false, but in the case of Python, it raises an exception if you are trying to get an index of a non-existent item. You can insert at a particular index an item, and it will shift everything that was at that index to the end of the list to the right one. You can pass a sort function that takes no arguments, call that method, and it will rearrange all the items in your list in ascending order. If you need to delete an item from a list, you can call the remove item method, and it will remove the first occurrence of that and shift everything to the right of it to the left one to fill in the list. If you want to reverse the elements of a list for some reason, you can do that with the reverse method. If you need to delete a particular element from the list, there's a delete or del method. If you call the sum method on an array, it will give you a sum of the values in a numeric sequence. There are also min and max, which will tell you the smallest and largest values in a list. To make a copy of the list, you must copy each element of the list. There are two ways to do that. You can create an empty list, create a for loop, and basically say for every element in my old list, stick it in my new list, or append it. It's probably easier to my new list. Or you can create an empty list and then use the concatenation operator to just say new list equals new list plus old list. Here's an example. When you copy list, we have a situation where both items would be referencing the same list. You can use list elements in calculations to calculate total of numeric values in a list. Like you said, we can seen before where we can use a loop over every element in the list and then use an accumulator value. If we need to get an average, we can add the total up and then divide by the number of elements in the list that we get with the length function. And list can be passed into functions as the argument list, or as an argument is maybe a better way to say that. A function can return a reference to the list. So a reference means it's going to point to it. If we need to save the contents of the list to a file, the list is going to have a write lines method, which will do that. Or if we need the new line character on the end of each line, we can write a for loop to write each element followed by a new line character. And to read data from a file into a list, or actually just to read it from the file, we would use the file object's read lines method to get that back. Okay, comprehensions, which I'm not really sure how they came up with this name. It seems a little weird to me. But basically, you are creating a new list by iterating over elements of an existing list. So the first one is where we create an empty list, list 2, and then, as I said earlier, we go through every element of list 1 and append it to list 2. And when this finishes executing, list 1 and list 2 are the same as far as number of values and values stored at each index. This way you can do it. Personally, I think it takes a little time to get used to, but we can say list 2 is a list, but I want it to have item for item in list 1. So what that will do is that will read every item from list 1 and put it here in place of the square brackets and create again an identical list. Okay, so this is just telling you that you have something called a result expression and then an iteration expression. So they're just telling you in this form of this comprehension what the pieces are. Here, item is going to return every value in list 1 like it did before, but notice we're using the exponentiation operator to square each value. So it will go over the items 1, 2, 3, 4, but what actually gets stored in the list is the square of those numbers, which is 1, 4, 9, 16. So you can do expressions right there at the beginning of the list. Here we're going through, and for each item we are taking the string, figuring out how many characters are in it. So just like len would tell you how many elements are in a list if you pass it a list, if you pass it a string, it will do the reasonable thing, which is to tell you how many characters are in the string. So winking is 6 characters, blinking is 7, and nod is 3. So that length list would have the values 6, 7, and 3 as shown here. You can use an if clause to go through and select only certain elements. So in this case, we evidently only care about the items that are less than 10. So it'll look at every element and it will basically remove or not carry over items that are 10 or greater than 10. Here they're showing you kind of the shorter but maybe more complex way to read the same thing as that for loop with an if statement inside of it. Here we are doing item for item in list 1 if item is less than 10. So it would basically remove the 12, the 20, and the 15, giving us the list 1, 2, 3, 4. Two-dimensional list, they call it nested list. In Perl, which preceded Python, they called them list of lists. So if you said that, somebody would probably know what you were talking about. But when we think about a list of lists, that is a two-dimensional array. And we think of two-dimensional arrays as having rows and columns. And there's a lot of things that two-dimensional arrays are really good for. When we're going through processing these, since you have rows and columns, typically we will have nested loops with each dimension having its own index variable. So this is a representation of a two-dimensional list. It has 3 rows, row 0 through row 2, and it has 2 columns, column 0 and column 1, and each location within this two-dimensional array has names within it. So to go through and okay, not sure why I wasn't advancing there. So here they're showing you the subscripts or the 2 indexes that we have to use. So the top left box, row 0, column 0 is going to be 0, 0. And notice that we use 2 sets of square brackets because there are 2 dimensions to this list. Now then, another thing we have is tuples, and it says that they are similar to list. I like to think of these as they're pretty much the same as list, just you cannot change the contents, which means you cannot add new values, you cannot delete values, and the values within the tuple cannot be changed. So to declare a tuple so that Python knows it's a tuple instead of a list, we use normal parentheses instead of square brackets. So the first example, under creating a tuple, we create a 2-element tuple that has 2 values. Now, if we have a tuple that's only going to have 1 value, we do have to put that value and put a comma there so that Python knows that we're declaring a tuple, a list of 1 that is not changeable. A lot of the list operations that we have through methods we have for tuples. We can use indexes. We can call the index function. We have length, min, max. We can slice tuples. We can use the in or not in operators. We can use concatenation and repeat or repetition operator on tuples. However, there are some things we can't do. Since we can't change the list, all these methods don't make sense. Append, remove, insert, reverse, or sort, because those would actually try to change the contents of the tuple. The tuple itself is immutable, but what they're trying to show you here down at the bottom is the third element of the tuple points to a list. The list it points to can be changed or is immutable. So the tuple can't be changed, but items it points to can be changed. So here they are showing you that we have a tuple. It's 2 numeric values and then a list of 3 values. If we print it, it prints out just like it looks in the assignment statement. If we append 100 to the list that is at index 2 and we print it again, notice that list at index 2 of the tuple actually now has a new value, which is 100. Why would we want to use tuples? Well, tuples are faster to process instead of list. They can provide some safety. If you have something that should never change, it makes sure that it doesn't inadvertently get changed. And there are some operations in Python that do require the use of tuples. There are a couple of functions that they mention here. There is the list function, which converts a tuple to a list. And then to do the opposite, there's a tuple function that converts a list into a tuple, or returns a tuple. So this has gotten us a little bit more content-wise than halfway through chapter 7. We're going to get ready to shift gears and talk about, we'll still be talking about lists and tuples and that type of thing, but we're going to be talking about Python module that we haven't talked about before and how to use it, in particular plotting data. So I think I'm going to end this lecture and call it part 1, and then I will come back and make a part 2 that finishes off chapter 7.